Okay guys, so I know we finished Module 2 in class. I just wanted to work through a couple of the on your own problems with you to help prepare you for your test. So let's look at on your own problem 2.5. It says, when 24.0 grams of the element carbon, C, react with 8.08 grams of the element hydrogen, H, natural gas, the same stuff that is burned in a gas stove or gas furnace, is produced. There's no leftover carbon or hydrogen. When these quantities are used, how much carbon and hydrogen would you need to make 128.4 grams of natural gas? Okay. So on your own, 2.5. Okay, so your problem tells you that when you have 24.0 grams of carbon plus 8.08 grams of hydrogen, it's going to give you natural gas. Okay, you know from the law of mass conservation that if you add these two up, you're going to get how much natural gas you get. So 24.0 grams plus 8.08 grams. It's going to give me but because of significant figures, it's going to be 32.1. Okay, so we get 32.1 grams of natural gas. Okay, so now it wants me to figure out what my formula would be in order to make 128.4 grams of natural gas. I did an example like this in class. So if I want 128.4, I need to divide by what I have to get my factor. And that is going to give me a factor of 4, okay? In order to get this amount right here. So I take my factor 4, I go back to my original formula. So I need to multiply this by 4, okay? And that's gonna give me 96.0 grams carbon, plus I multiply this by 4, and I'm going to get 32.3 grams of hydrogen, and that's going to give me what I want, 128.4 grams of natural gas. Now, when you do the law of mass conservation here, I do want to make a point, 32.3. It's going to be off by 0.1 here because of the way we had to round for significant figures, and that's okay. It's well within the range, okay? So this is the formula that you'll need for this problem. Now let's look at on your own problem 2.6. It says, a chemist decomposes 60.0 grams of the purple powder into 32.8 grams of the elements chlorine and an unmeasured amount of the element cobalt. The chemist uses the results of this experiment to help him determine the recipe for making this purple powder from its elements. He then decides to make 2.00 kilograms of it. How much cobalt and how much chlorine gas will he need? All right, so for on your own, 2.6. There is 60.0 grams of a purple powder that's decomposed into 32.8 grams of chlorine. Is that right? And an unmeasured amount of cobalt. Okay, we know from the law of mass conservation okay, so it's going to be 27.2 is going to be my amount up here. grams of cobalt. Okay, so hopefully you can see how I got that. All right, so this is going to help the recipe, right? So then the chemist is going to make 2.00 kilograms of the purple powder, right? First thing I want to do is change this to grams because that's what I'm working with. So if I put it over 1 and then I multiply 1 kilogram, 1,000 grams, I'm going to get 2.00 times 10 to the third grams of purple powder. So now I can use the factor. I need to get the factor method to plug in the factor to plug into my recipe to get what is needed, okay? So with 60 grams, when I made 60 grams, then I'm going to multiply it by some factor that's going to give me what he's trying to do now, just 2.00 times 10 to the third grams. Okay, so when I divide that out, I get my factor of 33.3. And it says how much cobalt and how much chlorine gas will he need. So that's the factor I multiply. So I go back to my formula. I'm going to multiply this by 33.3, and I'm going to get 1090 grams of chlorine. If I go here, I multiply by 33.3, I'm going to get 906 grams of cobalt. And that's how you do this answer. And then as far as significant figures, it should be 3, 1, 2, 3, 1, 2, 3. So we're good there. All right, hopefully these make sense to you. These will help you as you prepare for your tests. All right, and lastly, I just want to give you a few reminders. Remember to know about Dalton's 4 assumptions. I want you to know the difference and know what they are. The law of mass conservation and the law of definite proportions. Know what they are and how to explain them to me. Know the difference between mixtures and pure substances and be able to identify them. Please, please know if a compound is covalent or ionic. We talked about that, what it means. You're going to be able to need to recognize those. And also naming, what we practiced yesterday in class. Okay? Good luck on your test. Remember, show me all your work for full credit. If you do not show me all your work, you will have deductions. Always include units. And don't forget about your significant figure rules.